Hello, good selves. Welcome to the Pedagogical Science Institute for the People, and my name is Ndondi Wo. In this lesson, I just want to do with you the maths revision series in this topic of algebra. Okay, let's take a look at your Department of Basic Education examination guideline. You can see that algebra, equations and inequalities, it has 25 marks. So it's a lot. Then let's look at what is expected of you, or what will be examinable and what will not be examinable in this chapter. Solving equations by completing the square will not be examinable. There won't be any algebra question that will need you to complete the square to solve that equation. And number 2, solving quadratic equation using the substitution method, that is the K method, will be examinable. So we have to also learn that. Equations involving sets that lead to quadratic equations are also examinable. And solution of non-quadratic inequalities should be seen in the context of functions, and also nature of the roots will be tested intuitively with the solution of quadratic equations and in all the prescribed functions. So we'll actually look at nature of the roots, and we'll proceed like that. Okay. Okay, let's first take a look at equations. And in this lesson, you're gonna know how to solve for x using probably all possible questions that they can examine in the examination. So let's start with this question. It says solve for x in each of the following. You are given minus 4x squared is equal to 8x. Then the question says solve for x. Now if you want to solve for x, given this equation, what you simply do, you put the things on the same side, that is, you transpose. You can either transpose 8x to the left side, or you can either transpose minus 4x squared to the other side. So I'll actually transpose minus 4x to the other side, then I'll be left with 0 here. Then this side will be 8x plus 4x squared. 8x plus 4x squared. Now to solve for x, you can see that we have a common factor of 4x in our equation. Then we'll just take 4x as the common factor. Then you'll be left with 2, because 2 times 4x, it will be 8x. Then this side you'll be left with x, because 4x times x, it will be 4x squared. Then you can see now, in order to solve for x, we can use the 0 factor rule, where each factor will be equated to 0. So we'll equate 4x to 0, or we equate 2 plus x to 0. Then we can solve for x. This side I'm going to divide by 4, then my x will be equals to 0. Or let's go this side, we're going to transpose 2 to the other side, then my x will be equals to minus 2. So that's basically how you solve for x given such equation. Take common factor, then 0 factor rule, each factor equated to 0, then you solve for x. Okay, let us look at the second question. It also says solve for x. Solve for x. Now you can see that you are given factors that are equated to 0. Then you have to think of the 0 factor rule, right? Each factor will be equated to 0. Then you solve for x. So this one is simple. Just say x is equal to 0, or x minus 5 is equal to 0, or x minus 5 is equal to 0. So x is 0, that side is fine. Then here we can transpose minus 5 to the other side. then our x will be equal to 5. Okay. Okay, let's take a look at the second example. We are still under equations, and they say solve for x in each of the following. So now take a look at your given equation. It's x into x minus 5 is equal to 2, right? Now you can't apply the zero factor rule because your factors that are multiplying each other, they are not equated to 0, but they're equated to a certain value, right? So now, in order to solve for x, you'll first expand on your right hand side, then on your left hand side you'll first expand, then you transpose 2, maybe you check if whether you can factorize, then you can solve for x. So what we'll do in this question, our x will be multiplying with x, our x will also multiply with minus 5. So x times x, it will give us x squared, x times minus 5 to give us minus 5x. Then if I can transpose 2 to the other side, to be minus 2 is equal to 0. Minus 2 is equal to 0. Now we can check if whether we can factorize, right? So look, what are the factors of 2? It's 2 times 1, right? It's 2 times 1, finished. Can those factors, maybe if we add them or subtract them, give us minus 5? No, there's no such. 2 and 1, there's no way they're going to be 5, right? So it means we can't factorize this quadratic equation. So if you have this case where you can't factorize this quadratic equation, what you do, you use the quadratic formula. Simple. So we're going to use a quadratic formula in order to solve for x, and that's the formula for the quadratic equation. It's minus b plus or minus root of b squared minus 4ac divided by 2a. So we're just gonna substitute. We know that b is the coefficient of x, which is minus 5. So it's minus into minus 5 plus or minus root of our b. It's minus 5. It's minus 5 squared minus 4. Our a is the coefficient of x squared. So it's 1. Then our c is the constant term, which is minus 2 divided by 2 into our a is 1. Then we're just going to solve for x here. Then let's simply use the calculator and then get the value of x. So you can simply use your calculator, simplify. Some instruction will say round off your answer to 2 decimal place. Then you just simplify that using your calculator, you round off your answer. Okay. Now, let us look at this other example. We're still under equations and we want to solve these given equations. So you're given x squared minus 5x plus 6 is equal to 0. This is solve for x. So now, if you're given a quadratic equation and the question says solve for x, what you do, you first check whether that quadratic equation can be factorized. Is it factorizable, right? So if it's not factorizable, what you do, you use a quadratic formula. You substitute a, b, c, you solve for x. So let's look. What are the factors of 6? Factors of 6 is 6 times 1, perfect. Also 3 times 2. Those are the factors of 6, right? So now, let's take a look at the factors of 6 that maybe when we are adding them together, we're going to get minus 5, right? If we're adding them together, we can get minus 5. When we multiply them, we get 6, but when adding them together or subtracting them together, we can get minus 5. So 3 and 2, right? 3 and 2. So then we're going to open 2 brackets, equated to 0. Here it's x, here is x. Then let's see, 3 and 2, 3 times 2 is 6. Then how can we add them together to get minus 5? If we take minus 3 minus 2, it will be equals to minus 5, right? So it means we'll have minus 3 and we'll have minus 2 there. So then you see that, let me just delete this. you can see that your factors now are equated to 0. We can use the 0 factor rule. So each factor equated to 0, then you solve for x. So I'm going to say my x minus 3 is equal to 0, or x minus 2 is equal to 0. Then we're going to solve for x. In this case, we transport minus 3 to the other side. X is equal to 3, or in this case, we transport minus 2 to the other side. Then our x will be equal to 2. Okay. Okay, grade 12s. Let's now move to inequality equations. And what we'll be basically doing is solving for x, but now we want to focus on inequality equations. Okay, you're given an inequality. How do you know this is an inequality equation? There's no equal sign, right? But there's an inequality symbol which is greater or equal to. So that's an inequality symbol. It's not an equal sign. So now we call that an inequality equation. So you're given that equation. They say solve for x, right? But we can see that this is a quadratic equation only if we can transpose the 20 plus x to the other side. Then we just have our quadratic equation. So that will be our first step. We say x squared minus 20 minus x will be greater or equals to 0. Okay, let's write it properly. We can just simply say x squared minus x minus 20, so that we may just have our quadratic equation in that orderly manner. Okay, now we have x squared minus x minus 20 is greater or equals to 0, right? Now, because there's no equal sign, right, what you can actually do, you can get the critical values. We call them critical values. We assume there is equal sign and we solve for x. And those values of x are not our final answer, but they are our critical values, very important values, right? So in order to get them, in this case, we can actually factorize by opening two brackets, greater or equals to 0. Then if we want to factorize factors of 20, I think to be 4 times 5, then we can see that when we subtract them or add them there, we can get minus 1. Only if we can take maybe minus 5 plus 4, then it will give us minus 1, that value in the middle. So we see our factors will be x minus 5, then x plus 4. So those are your factors now. They are your factors. Now what do? You get the critical values. I'll just call them CV, critical values, right? So when you want to get the critical values, I said you assume there is equal sign and you solve for x, right? So if there is equal sign, actually we're going to use 0 factor rule. X minus 5 is equal to 0, then our x is equals to 5. That's our critical value, or our x is equals to negative 4. So those are our critical values. After getting the critical values, what do? You draw a number line, right? This is your number line. Then you go where there is minus 4, you go where there is 5, right? So now it's very important. Remember, this is a quadratic equation, right? It's a quadratic graph, right? Check at your value of a. Your value of a is positive 1. It means that this graph will be a smile. It will be a smile. It's a smile. You can see it's a face smiling. Okay, so now how do you get the final answer, right? So you check your symbol for the inequality. Let me just write it properly there. It's greater or equals to 0. Okay, you check. This is a quadratic graph. Where on your graph is your graph above 0, right? On top of 0. Okay, now you have to think of this line as 0. This line, we call it, it's 0 because the y at that line is 0, right? Y is 0. So where your graph is above, that is when it's greater. Remember, check the symbol there. It's greater or equal to 0. So where your graph is above 0, that is above the line. So it's in that interval there. Your graph is above. Then you can give your final answer. You can say it's when x, we can see we are moving backward here. It's when x is less or equals to -4, or let's see this side, or when x, if we are going there in front, that's where our graph is being above, when x is greater or equals to 5. So that will be your final answer. Okay, let us now solve this other equation. This one we just solved it now. Let us solve this other equation, and we are still on inequality equations. You are given x into x minus 4 is less than 0, right? Okay, now because this is an inequality equation, you first check, can I get the critical values from this equation given? And the answer is yes, we can get the critical values, right? Because we are going to assume that this inequality equation is equated to 0, then we can get our critical values. So we can just go straight to our critical values. Then we assume the equation is equated to 0, then you solve for x. Then we use the 0 factor rule. X will be 0 or x will be equals to 4. So that are your critical values. They are not the final answer, right? So let's go and look for the final answer. Let me just draw this line properly. So we go where there is 0 and where there is 4 on our number line. Then now you check your value of a from your graph, right? If I were to expand this, I would multiply x, and it will be give me x squared, right? So if you check my value of a there, it's 1, it's positive 1. It means it's a quadratic graph with a smile. It's a quadratic graph with a smile there. So now you check. We set this line here. You assume this line is 0, right? It's 0. Sorry about this. You assume this line is 0. Then what do? You are going to check, because the symbol, the inequality symbol there, it's saying less than. So it means it must be under 0. So let's check our graph. Under 0 is that interval between 0 and 4. That's where the graph will be less than 0. So the final answer, we can write it. It's when x is between 0 and 4. Our x must be between 0 and 4. Okay. Okay, great stuffs. We're still on inequality equations, and let us take a look at this other interesting example. Okay, now this is a little bit challenging, and because now this is not a quadratic inequality equation, but it's sort of a combination of an exponential equation and a linear equation, because we have two exponent x and we also have 3x plus 1, right? So now we say, if you want to solve an inequality equation, what do? You first check whether it is possible for you to determine the critical values. How do you do so? You assume the equation is equated to 0, then you solve for x. When you solve for those x, those are your critical value. Those are the values that are going to be very, very useful throughout your solving, and they will help you to get the answer. So let's check. We assume the equation is equated to 0, then we solve for x, right? So we're just gonna show them that now we need our critical values. So we can use the 0 factor rule to solve for x here, because it's possible to solve for x much better in a fastest way. So we can say 2 exponent x is equal to 0. Remember, we need the critical values, right? These are not the final answer, are just critical values, important values that are going to help us. Or we can say 3x plus 1 is equal to 0. Then we know from this equation we won't be able to solve for x, right? Because there is no any 0 cannot be raised to the power of 2. So there's no answer that side. Let's move to this side. Just gonna solve for x with transpose 1 to be minus 1, and we divide by 3 both sides. Then our x, which is our critical value, is minus 1 over 3. So it's the only value in this equation. So we're gonna draw a number line and we go straight to, maybe it's probably somewhere there, minus 1 over 3, right? It's minus 1 over 3. So because now you don't have a shape of a graph, it's not like a quadratic graph like the previous questions we have been doing, where we say, okay, just take the shape of the graph, then where if it's less than you go down, if it's greater than you go on top and check there. Now it's different, right? So now if it's like this, where it's not forming a quadratic graph, what you do is you use a trial and error method. You just test on which side will this thing will be less than 0, right? So in order to test, it's either it can be on this side or it's either it can be on this side. We don't know, right? So we are going to actually test. So how do you test? Because it's less than, we use an open circle to show that it's not included. Minus 1 over 3 is not included, and we're just going to test on the sides, right? So on this side, actually we know that on this side we can have minus 2 because we are moving to the negatives, but on this side we can have 1, 0, you see, something like that, because we are moving on the positive. So let's just choose 1. So we're going to test with minus 2 and check whether really, if we substitute minus 2 where there is x, if we substitute minus 2, will we get an answer that is less than 0? If we get an answer that is less than 0, then our arrow will point that side, right? It will actually point the same side for minus 2. But if we get an answer that is not less than 0, then it will be the other way around. So let's go and substitute minus 2 in that equation. So I'm going to say 2 exponent minus 2 in my calculator, 3 times minus 2 plus 1. Then the answer that I'm getting minus 5 over 4. And we know that minus 5 over 4 is less than 0, right? Minus 5 over 4 is less than 0. So we tested this side on the left hand side and it's true, right? It means our arrow is going to point on the same direction. So our final answer, which will be x is less than minus 1 over 3. That will be your final answer. Okay, so now let us move to exponential equations. And now you learn how you can solve exponential equations. Okay, let's take a look at this example. It's an interesting question. You are given 9 to the exponent of x squared plus x is equal to 27 to the exponent of x plus 1. So the question says solve for x. Okay, now because this is an exponential equation, what you can do if you're given this question, you can ensure that you make sure both sides of the equation have the powers of the same base. Why do we want to make sure that? Because if we know they have the powers of the same base, then we can equate the exponents, then solve for x. Simple as that. So ensure that they have the powers of the same base, raise them to the same, like the base must be the same, right? So that's what we do. And we know 9 is the same as 3 squared, then it's still multiplied to x squared plus x, then is equal to, let's check 27. 27 is the same as 3 exponent what? It's 3 exponent 3. So it's 3 exponent 3, but we still have, okay, we still have x plus 1 there, x plus 1. Then we can just remove from the exponent there, it will be 3, 2 times x squared, it will be 2x squared, then plus 2 times x, it will be 2x. Then it will be equated to 3 into 3 times x, it will be 3x. Then 3 times 1, it will be 3. Then now we have the powers of the same base. We can equate the exponent. So we just say 2x squared plus 2x is equal to 3x plus 3. 3x plus 3. Then now you can just transpose those things to the other side. Then I'll have 2x squared plus 2x minus 3x minus 3 is equal to 0. Then it will be 2x squared, 2x minus 3x, it will be minus x minus 3 is equal to 0. So let's check whether this will be factorizable. If it's factorizable, if it's not, or sometimes if you reach this point you see it's a quadratic equation, don't even stress yourself about factorizing, just use the quadratic formula and get the answer, right? But me, I'll just factorize here and see if it will be possible. So 2x times 1, it will be 2x, so that it can be minus, it should be positive, this should be negative, so that 2x minus 3x can give me minus x there. So then factors, you equate them to 0, 0 factor rule. Then your x will be 3 over 2, or your x this side will be equals to minus 1. So that's basically how you solve for x given this kind of exponential equation. Okay, let's take a look at this one we just solved it. Let's take a look at this other exponential equation, and let's see how we can solve it. So you're given 3 exponent x plus 3 exponent x plus 1 is equal to 12, right? So they say solve for x. So in this type of exponential equation that is separated by either positive or negative sign, what you do is that you break them, right? What do I mean when I say you break them? You write them in their factors. So 3 exponent x will just remain 3 exponent x plus 3 exponent x plus 1. We know it, we can write it as 3 exponent x times 3 exponent 1. So we assume you broke it, right? You break them like that. Okay, 12, and we know 12, it can be like, okay, let's just leave it at 12, right? Then we just take a common factor. We have a common factor this side, right, of 3 exponent x. If we take 3 exponent x as the common factor, if you want to get the answer inside the bracket, you assume you are just dividing, right? So you say 3 exponent x divided by 3 exponent x, you are left with 1 there. Then 3 exponent x divided by 3 exponent x times 3. Then, 3 exponent x times 3 divided by 3 exponent x. 3 exponent x will cancel with 3 exponent x, will be left with 3. Then this will be 3 exponent x into 1 plus 3 is 4, is equal to 12. Then we know we just basically divide by 4 both sides in order to solve that x. Then it will be, let me just write this side, 3 exponent x is equals to 12 divided by 4. It's what? It's 3, right? Then now, you know, if we have the powers of the same base, we equate the exponent. We equate the exponent. So now we just say x will be equals to 1. X will be equals to 1. So that's basically how you solve for x there. Okay, let us take a look at these equations, and it's quite a different equation because now we have to be using the K method, right? So there are some equations that you find they're very complex, such a way that you don't even know where to start, you don't even know what to do. So that's where you have to use the K method. Questions such as this: you're given x minus 3x exponent 1 over 2 is equal to 4. Right? So how will I know that in this equation I have to use the K method? Very important question. Okay, now if you want to know whether you have to use the K method or not, you just check your equation, right? You check your equation. Okay, take a look at this equation. You have x exponent 1, right? But then as you move to the second term, you have minus 3x exponent 1 over 2. Now you check the exponents now. They are not the same. The other one is 1, the other one is 1 over 2. It's those kind of equations where your exponents are not the same. Now you have to think of the K method, right? If you find such kind of equation, such as this question. So how do we use the K method, right? So the one in the middle is the one that you equate to K, right? So what do I mean the one in the middle? The unknown in the middle, you equate it to K. So we say let K is equal to x exponent 1 over 2, right? The unknown in the middle, you equate it to K, right? So let K is equal to 1 over 2. I mean x exponent 1 over 2. Now, if our K is x exponent 1 over 2, what will our x be? Okay, this x, we have to replace this with K, right? So it's x exponent 1. How can we write this in a way that will include K? So we can say, okay, our x exponent 1 was found by x exponent 1 over 2 multiplied by to the exponent of 2. So if you say x exponent 1 over 2 to the exponent 2, 1 over 2 times 2 will cancel out each other. It will still remain x exponent 1. So when there is x, we replace by K, because our K is x exponent 1 over 2 squared, right? Because that is the same as x exponent 1. Minus 3. Then when there is x exponent 1 over 2, we say let it be equal to what? K. So we replace by K is equal to 4. Then now you have a simple and beautiful quadratic equation. Then you can just solve for x from this step, right? So you transpose 4 to the other side, and it will be k squared minus 3k minus 4 is equal to 0. Is equal to 0. Then you can just factorize in order to solve for k. We open two brackets. But if you are really not sure about factorizing, if you don't know how to factorize, simply use the quadratic equation, right? I mean the quadratic formula. Use the quadratic formula, substitute your a, b, c, get your answer. Don't stress yourself. So now here I'm just going to factorize bk to bk. Then let me check the values. 4 times 1, obviously, when I say minus 4 plus 1, it will give me minus 3. Minus 4 plus 1. So my k will be equals to 4, or my k will be equals to minus 1 when I use the zero factor rule. Okay, now my k is 4, my k is equal to minus 1. Then I go back to the equation there. Remember, we need x, we don't need k, we need x. So from k is equals to x exponent to 1 over 2. Also this side we can say from k is equals to x exponent to 1 over 2. Then I'm just going to replace k by 4 this side and solve for x. Then also I'll replace by minus 1 this side and solve for x. And solve for x. So in this case, I'm just going to square both sides in order to get my x. So I square so that these 2 and these 2 can cancel each other. My x is going to be 16. That side also I'll do the same, and I will just square there in order to get my x. So this is 1 over 2 precisely. Then it will just be, if I square this side and I also square this side, then I'll have something like, okay, let me just, sorry about this, it will be 1 is equal to x. So this will be my final answer. X is equal to 16, x is equal to 1. Let me just repeat this, right? How do I know I have to use the K method? Check the exponents, right? I have x exponent 1. That side in the other term, I have x exponent 1 over 2. So now, my exponents are not the same. You have to think of the K method. Let K is equals to that unknown in the middle term, right? Then you just use your math, you solve, then x is equal to 16, another x is equal to 1. Okay. Okay, we are still on exponential equations, but now I want to show you how you can solve for x in this exponential equation. But these kind of exponential equations are not the normal ones that we have been solving before. Now, this one will be using the K method in order to solve them, right? Okay, let's look at this question. It says 2 exponent 2x minus 6 times 2 exponent x is equal to 16. Then they say solve for x. Okay, how do I know that in this kind of exponential equation I'll have to solve for x? Those are the kind of exponential equations that you have tried everything you can and yet you didn't get the answer. So you have to think of the K method. 2. These are the kind of exponential equations where you check the exponents. They don't have the same sort of like they don't relate properly. They don't have the same coefficient. Look at the first term is 2 exponent 2x, right? But if you go to the second term, it's minus 6 times 2 exponent x. Now the coefficient of those unknowns are not the same. Now you have to think of the K method. How do I use it? Okay, I'll first take my 16 to that side so that I may have a stable, beautiful exponential equation. So it will be 2 exponent 2x minus 6 times 2 exponent x minus 16 is equal to 0. So just take that thing to the other side, then to have that stable exponential equation. Now I'm going to let me just quickly use this side. Let k is equal to, we say you equate it to the unknown of the middle term. Let k is equal to 2 exponent x. Let k is equal to 2 exponent x. So if my k is 2 exponent x, what will be my answer for in terms of k? 2 exponent 2x. So we can see they just say 2x, then they squared it so that it can be 2 exponent 2x. So that one will be the same as k squared, right? It's k squared minus 6. We say 2x is k, so it's minus 6k minus 16 will be equals to 0. Then now I can factorize or simply just use the quadratic formula. Don't stress yourself. So me, I'll just factorize, but you guys can use the quadratic formula, or if you can manage to factorize, just factorize. Never stress about it. So let's see, 16. So that we want the factors that will enable us to, the factors of 16 times 1, and we have 4 times 4, and we also have what? Other factors of 16. I think it's 4 times 4, 16 times 1, then what's next? What next? Let me think. 16 divided by, let me check. Okay, you see it takes time, so it's 8 times 2, right? So 8 times 2 is 16. Then if I say minus 8 plus 2, it will give me minus 6. So minus 8 plus 2 will give me this minus 6c. So that's it. So my k zero factor rule, it will be equals to 8, or my k will be equals to what? Negative 2. So k is 8 or k is minus 2. Then I can now go back and substitute my k to solve for x. So remember we said k is equal to 2x. When there is k, I can put 8 is equal to 2x, or I can put minus 2 is equal to 2 exponent x, not 2x, 2 exponent x. So this one, in order to solve, I can take 8 to the powers of the same base, which is 2 that side. So we know we have, to be 2 exponent 3 is equals to 2 exponent x. Then I can solve for x because the base now are the same. I equate the exponent. Then my x will be equal to 3. Then now here, There's no way the base can be the same. So in this case, x has no solution, no answer that side. So my x is 3 only. My x is 3 only. Okay. Okay, let's now do this last example on solving exponential equation using the K method. Okay, you're given that exponential equation is 3 exponent 2x minus 7 times 3 exponent x is equal to 18. Okay, now how do I know? I'm repeating this. How do I know that I'm going to use the K method, right? Check the exponents. The first exponent is 2x. The second exponent of the second term is x. They are not the same. They are not related, right? We know we're going to use the K method. That's how you see it. So let's quickly take that 18 that side because it will disturb us. Let's take it 18, go that side quickly so that we may have something that is proper here on our side. So take 18, we transpose you, there is nothing that side left. Okay, now let me just write this properly. It seems as if it's something else. Let me just write 2x. Okay, now we can let k, we are using the K method. We'll just say let k is equal to 3 exponent x. Let k is equal to 3 exponent x. Remember we said you equate it to the one in the middle. Now we know that 3 exponent 2x, it was just 3 exponent x mod x to the exponent 2. So it was our k, because our k is 3 exponent x, so there it will be k squared. Sorry about this. This will be k squared minus 7 times k minus 18 is equal to 0. Now we can factorize, or you can just use your quadratic formula. I will factorize and let's see if this will be possible. So 18 is the same as 9 times 2. If I say minus 9 plus 2, it will give me minus 7. So it's minus 9 plus 2. So my k will be 9, or my k will be negative 2. Then now I can go back and solve for x. I replace my k with 9. 9 is equal to 3 exponent x. So to solve for x here, I take them to the powers of the same base. Base is 3. Then I can equate the exponent 2 is equal to x. That will be my answer. Or I can go and substitute minus 2 is equal to 3. Woo, it's messed up now. Sorry about this. We just have a small space here. So it will be minus 2 is equals to 3 exponent x. Then we see there's no way minus 2 can be a base of 3, can have a base of 3. So let's forget about it. There's no answer that side. So x equals to no solution, not applicable, something like that. So x, our x is 2 only. Then our x will be 2. Okay. Okay, great tops. We now move to sets and squaring both sides. Sets and squaring both sides. How to solve this kind of equations? You are given a set and you just see it's 2 minus x in a square root. Then it's equated to x minus 2. And you want to solve this kind of equation. And how do we do it? Okay, so what you do, because this is a set, you have to square both sides, right? You have to square both sides. Why are we squaring both sides? We want to remove the square root. We know the only poison for a square root is a squared. You square both sides. That's the only poison that can kill a square root. So you square both sides. So we square this side and we're gonna square also that side. Once we square, the square root is gone. It's dead. So it will be left with 2 minus x is equal to what? X minus 2 squared, right? But x minus 2 squared, we can write it x minus 2 times x minus 2. Then we can just expand that and simplify it. So 2 minus x to be x times x, x squared, x times minus 2x, that other minus 2 times x minus 2x minus 2x minus 2x minus 4x minus 4x minus 2 times minus 2 plus 4. Okay, now we can transpose, we can take those one from the left to the right hand side. So we'll be left with 0 there. We'll have x squared minus 4x plus 4. The x side plus x minus 2. Then it will be 0 is equal to x squared minus 4x plus x, like terms, minus 4x plus 4 plus x, it's minus 3x. Then 4 minus 2, it's positive 2. Then we can factorize or use your quadratic formula. I've been saying this a lot. Just use your quadratic formula to be on the safe side. Remember, this is metric. You don't want to make any mistake, so it's better to stick with the quadratic formula. As we've been doing maths for a long time, we can just use the factorizing method. But if you're good at factorizing, just factorize. But the quadratic formula, it's a safe formula for doing this. So factors of 2 is 2 times 1. There's no any other factors, but we want to ensure that they give us minus 3, right? So it must be minus 2 minus 1, so that it can be minus 3. Great. Then now we can solve for x. My x, now zero factor rule, x minus 2 equals to 0, x minus 1 equals to 0. Then my x is equal to 2, or my x is equal to 1. Okay, listen very carefully. Now, when you are solving for sets, such equation like this that have a root, always notice that there is one answer that is incorrect, right? There's one answer that will be incorrect. What do I mean incorrect? When you go and replace and prove there, it won't give you the answer. It will give you a negative root, and you know there's no negative root, it's error. So you always have to check and you choose your final answer, right? So we're going to prove. You're going to substitute 2 on the original equation. So it'll be root of 2 minus 2. It gives me 0, right? Let me go to the right hand side. 2 minus 2, it's also 0. It means 2 is fine. 1 is not correct. Let's go and prove it. Root of 2 minus 1. It's giving me 1, right? Root of 2 minus 1, it's 1. But if you go on the right hand side and you substitute 1 there, it will be 1 minus 2, which will be negative 1. 1 and negative 1, they are not equal. So this answer is not applicable. So always when you are solving equations that have sets like that, square root, always notice there's one answer that is correct, one answer that is not correct. So you have to conclude, therefore, x is equal to 2 only. Then you get another mark there. Wow, finished. Yeah, that's it. Okay. Okay, we're still on sets and squaring both sides, right? But now, this is a question. It's quite different from the one we just did right now. Now, you sort of have another value there, another term there. What does it want? There is a 4 there interfering with us. It wants to interfere with us. Okay, now, this is a quite different question. Why? On the previous question, it was like there was one term squared, then the other side on the other side. That's we say we square both sides. Now, the mistake that many students do when they see questions such as that have square root, they just think of squaring both sides quickly. Wow, squared. We square both sides. That's what we have been taught. No, it's not correct. So in this case, what you have to do, you have to ensure that something in the square root, they are alone, the other things, they are alone that side, right? Then you can square. That's what you do. So we're going to take the 4 and transpose it, put it the other side. We don't want to make mistake. So we'll be left with x plus 2 is equal to x minus 4. When it goes that side, it's minus 4. Now we can square. It's perfect. We can square now because things are standing on their own. Okay, once we square, like I said, is the poison for what? For square root. It kills the square root. then you'll be left with x plus 2 is equal to x minus 4 squared. It will be x squared minus 4x giving me minus 8x minus 4 squared to give me positive 16. Then I can just take those things to the other side. Then it will be x squared minus 8x plus 16 minus x. Okay, here I'll be left with 0 minus x minus 2. Okay, we have 0 this side is equal to x squared. Let me add the like term, minus 8x minus x, it will be minus 9x. 16 minus 2, it's 14. Then I can just factorize to solve for x. Then this is x, this is x. Factors of 14. Okay, let me just do this properly. Factors of 14, 7 times 2. Minus 2 minus 7, it will give me minus 9. Minus 2 minus 7. Then I can use the zero factor rule. Then basically my x will be equal to 2 or x will be equals to 7. Let's wait. We said any said equation, if you are solving for x, there is one answer that is incorrect. You have to verify now here. You go back and substitute 2 on the original equation. You see whether it will give you the answer. So it will be root of 2 plus 2 plus 4. It's giving me 6. It's giving me 6 on my calculator here. Okay, let me just show you. Root of 2 plus 2 plus 4. It's giving me 6. If you can check on my calculator, it's 6. Right? So, and we know x is not 6. X we had substituted 2. We had substituted 2. Now it's giving us 6 that side. It's not correct. So this one is not applicable. Let's prove with 7. So it will be root of 7 plus 2 plus 4. It must give me 7. So this one is correct. I substituted root of 7 plus 2, plus 4, and then it give me the same 7, which was my x. So this one is correct. Therefore, I must conclude x is equal to 7 only. You get a mark for doing that. So don't be in a hurry when you are writing these questions. Check. Go back and verify. Yeah. Okay, let's now come to the last part of our lesson today. And this is nature of the roots. And I hear most of you learners really struggle with nature of the roots. You say it's difficult. Oh, nature of the roots is difficult. No, nature of the roots is very simple. You just need to understand. You just need to understand. Finish. Understanding is key. Okay, let's look now. Okay, I'll first teach this a bit, then we just do some examples, then that will be enough for today. So it says for a quadratic equation, okay, for a quadratic function f of x is equals to ax squared plus bx plus c. The solutions of the equation f of x is equal to 0. Right? If we say f of x equals to 0, we are going to solve for x. So we call that the roots, right? We call them the roots of f of x because we are saying f of x equals to 0. Whatever we solve to be the roots of f of x, right? Now, when we say nature of the roots, we mean those roots, those values of x that you're going to get after equating f of x to 0. You are going to solve for x. And those x that you get are the roots. We call them roots, right? Then, when we say nature of the roots, we mean the nature of this value. How are they? That's it. Then we are done with the nature of the roots. It's finished like that. Nature of the roots. How are they? When we say the nature of this plant, how is that plant? It's sort of like a descriptive part of the plant, right? So we call it nature of the roots. So let's continue. is given by the formula x is equal to, in order to solve for x, because it's a quadratic equation, we can solve for x using a quadratic formula. That's a quadratic formula, x equals to minus b plus or minus root of b squared minus 4ac divided by 2a. Then now, what is very important now? If you want to know the nature of your roots, right? If you want to know the nature of your roots, you must calculate something called delta. Delta. Let me just write it. Delta will help you to determine the nature of your roots, right? So delta is found inside the square root there, and we can deduce its formula. Delta will be equals to b squared minus 4ac, because it's inside this root there, which is actually that thing inside, b squared minus 4ac. After calculating delta, so there are certain things that you have to know about delta. When it's like this, the roots are real. When it's like this, the roots are equal. When it's like this, the roots are non-real, right? So let's just look at it quickly. What happens when the roots are sort of like in this way? Okay, look at this diagram here. Let me just point now. Just take a look at this diagram. Now, if the roots are non-real, right? Now your delta must be less than 0. That is, you get a delta that is negative, because less than 0 is negative. If your delta is negative, then we are saying the roots are non-real, right? In other words, there is no roots. Okay, look at this example, the graph they drawn for you. This is your quadratic graph. Does this quadratic graph have an x-intercept? No, there's no x-intercept here. Or someone can just say, no, but there's no x-intercept there. There's only y-intercept, no x-intercept. Then we say the roots are non-real. They don't exist, right? Another word for non-real, they can say undefined. Sometimes they can say undefined. So if it's undefined, there are no roots, and you can actually see it yourself that there's no roots here. This graph is cutting on y-intercept. Also, this graph is cutting on y-intercept. So that is when your delta is less than 0. We say no, no roots. 2, roots are real and equal. If the roots are real and equal, now it is when your delta is equal to 0. You have to know these things. When your delta is equal to 0, your roots are real and equal. Then that's where your graph is like that. You can see there's only one root, right, on the turning point, and it's like equal because it's 2 of them. When on the turning point we have 2 values, so sort of like 2 of them. So we say those 2 are the same. They're equal. The roots are equal. It's only one root. They're equal. If it's 1 there, then our root is 1. It's equal. So it can be that shape. So let's go when delta is greater than 0. Now, when delta is greater than 0, what happens? Now, if your delta is greater than 0, right, we said the roots are real. But because it's just greater than 0, it's not equal, we say they are unequal. But sometimes you can get delta is greater or equal to 0. That is when the roots are real and equal. We say delta greater or equal to 0, right? So when the roots are real, they can either be 2 kind of roots. They can be rational roots or they can be irrational roots. So for rational roots, it is when your delta, it is a squared rational number. When your delta is a squared rational number. For example, if I calculate my delta and I get my delta as, let me say 49. You know that 49 is a squared rational number because you can write it as 7 squared. So this one, we would say these roots are real and rational. Why? Because the delta is a squared rational number. It can be squared, and when you apply a square root, you can just get an answer straightforward there without any comma. But then if my delta is greater than 0 but not a squared rational number, then we say they are also real but and what? Irrational. For example, it's when you calculate delta is equal to 2. 2 is not a squared rational number, right? Because if you say square root of 2, you just get other numbers with comma, 1, comma 4, 1, 2, 4, 2, something like that. So we say now the roots are real, but they are irrational because our delta is not a squared rational number. If it's a squared rational number, we say they are real and rational. Okay, let's quickly go and look at some examples in order to enhance your understanding on this. Okay, you are given the roots of a quadratic equation is given by x is equal to minus 2 plus or minus root of 4 minus 20k divided by 2. Then they say determine the value of values, right? Value or values. It means it can be one or more. Okay, of k for which the equation will have real roots. The real roots, they don't care about a rational or what or irrational, they just say for which the equation will have real roots. They didn't even tell you they are unequal, right? So when they just say real roots, you assume they are also equal, right? So now what do you know about delta? In this case, our delta must be greater or equals to 0. That is for real roots. What is my delta? My delta is equals to b squared minus 4ac. Where can I get b squared minus 4ac? Inside the square root there. So you can see our delta is equals to 4 minus 20 multiplied by k. 4 minus 20 multiplied by k, it's our delta there. Then we can just basically go and solve for k for which the equation will have real roots. Now because my delta is 4 minus 20k, because for real roots is this condition, then I can substitute and solve for k. Simple as that. So I'll say 4 minus 20k is greater or equals to 0, then solve for k. And to solve for k, I can take minus 20k, I can transpose it to the other side, then it will be 4 greater or equals to 20k. Then I divide by 20 in order to solve for k. Divide by 20, this 20 multiplied by, cancel out that one, then k will be less or equals to 4 over 20, I think it will be 1 over 5. So our k must be less or equal to 1 over 5. That is all the values of k that will ensure that the equation will have only real roots. Okay. Okay, we're still on the same question, but now this is a different question. It says determine the values of k for which the equation will have non-real roots. Non-real roots. So for non-real roots, what's the condition? Delta must be less than 0. If it's non-real, there's no roots. It's unequal. It's undefined sometimes. No solution, not applicable. Non-real roots, no roots, something like that. So delta must be less than 0. What is our delta? Something in the square root there. It's 4 minus 20k. So we just say, sorry about this. To be 4 minus 20k is less than 0. Then it's 4 minus 20k is less than 0. Then I can take 20 that side, so it will be 4 is less than 20k. When it goes that side, then I divide by 20, and this is cancel this one. My k will be greater than 1 over 5. K will be greater than 1 over 5. So that will be the answer. K, for all values of k, when k is less than 1 over 5, they will ensure that there won't be any real root. There will actually be non-real roots. Okay, let's now look at the last example. We're still on nature of the roots. So determine the values of k for which the equation will have equal roots. Don't forget that when I was teaching you nature of the roots there, what we say about equal roots, it's like They are equal there, so delta must be equal to 0. That's the condition. Delta equals to 0. You get the answer for just writing that. So because it's equal roots, then what is our delta? It's 4 minus 20k. It's inside there. It's b squared minus 4ac, right? So it's 4 minus 20k is equal to 0. So sometimes they won't give you something like this. Sometimes they will just give you a quadratic equation. You just need to calculate your delta yourself by using the formula delta equals to b squared minus 4ac. You take your b, you square, minus 4, you take your a, you multiply with c, you simplify. That will be your delta. But then this one is quite simple because we just given it in the form of a quadratic equation, sort of like. Then we know inside the square root is b squared minus 4ac. We take it as our delta, right? So let's solve for k. Then just take 4, we can take minus 20k to the other side to be 20k, and we divide by 20, we divide by 20, this cancel this, our k will be equals to, let's see, 4 divided by 20, we already calculated it, it's 1 over 5. I don't know why I'm pressing a calculator. So k is 1 over 5. It's only when k is equal to 1 over 5 where the roots of that equation will be equal. So that's it. Okay, yeah. Now it's just a summary, quick overview of what we covered today, and we really revised quadratic and inequality equations. We did many different examples just for you to know how you can solve, you can approach certain questions. Remember, algebra is 25 marks, so it's very, very important for us to do those kind of questions. But I would also encourage you to go to past papers and treat more and more questions that are sort of like related to those. And we also focus on the exponential equation. There were some exponential equations that were easy to solve. I mean, you just go straight forward, you raise the powers to the same base, you get the exponent. Some exponential equation we had to use the K method, as in outlined in the examination guideline. It said we have to use the K method with some of the equations. We also focus on sets and squaring both sides, and where you learn, there's very important knowledge. There's always one answer that is not correct, so you have to prove. In this case, you go and substitute, you check whether the answer was correct or not. We lastly focus on nature of the roots. Interesting section. Most of the students find it challenging, but I hope after this lesson you have learned and you enjoyed this session. Okay. Okay, so these are some of our references. We use the basic Department of Education to just get some of the past papers and the examination guideline there, and also Siavula to get some of the things of nature of the roots. You can click on their sites, and also we acknowledge the WTS tutoring, where we used one of their documents to extract some of the questions there, and you can just follow them on their sites and download those kind of questions. Thank you very much for watching, for joining this session, watching us today. This was just a maths revision series from me, Ndondibuo. Thank you very much. Mathematics has never been this easy. And don't forget, you can visit our site on sites.google.com/view.pedagogical science institute, or you can visit our Instagram page. It's pedagogical_science_institute, or you can also visit our Facebook page at Pedagogical Science Institute. Also, you can visit us on our Twitter page and at Pedagogical Sci, and also obviously on our YouTube channel, Pedagogical Science Institute. Thank you very much for joining. That's it for me. Enjoy the rest of your day. Thank you.